But here's to say your trusted advisor. Let's talk about SQL databases in Fabric. Basically, SQL databases in Fabric make things easier. You have an integrated SQL database right in Microsoft Fabric in the platform. You have all the benefits of the platform, which means unified security, automatic mirroring, and the ease of administration. You don't need a resource group, you don't need Azure access, and so on. That's basically the story, and I love it a lot because, well, data is nearby, everything is in one platform, and I still have all the benefits of a full-fledged SQL database. But let's go a little bit into the details. So let's have a look at our Fabric periodic table. When we search for SQL database, you see there's a SQL database with a short description. The naming prefix is suggested is SQLDB, and the CLI suffix is SQL database. You don't have any minimum licensing requirements beside of having a Fabric capacity. And the key features are you have a great SQL database engine, which I love a lot. You have a REST endpoint when you want to access the data. You don't have currently Fabric CLI dedicated support for Fabric SQL database. Let's go a little bit into the core concepts. Let's say you have an application like an application. Let's like in the web app. And this web app application, that's an app, needs a database. That's basically the main use case. You need a database for an application, and yes, of course, you have SQL endpoints in Fabric, but these SQL endpoints don't support the full spectrum of all SQL commands and are usually not supported directly by any app, but SQL Server is. So now you have SQL Server in Fabric. How it is working? So we have basically a Fabric workspace. And this app accesses your SQL Server inside of your Fabric workspace. So you have your SQL DB engine inside of your Fabric workspace. That's one of the benefits. You have Fabric permissions. So you can simply, there's a SQL endpoint, you can simply point your web app to your SQL database engine right into your Fabric workspace. And you have, of course, an attached storage. This is an SSD storage where this engine writes to. But beside of that, it uses the Fabric capacity. So it uses the vCores of your capacity. Let's draw it here, vCore of your capacity. That's also helpful because you don't need additional budget, right? It's still like software as a service, everything running in one place. So what's the benefit? Yes, you have the workspace. Yes, it runs on top of your capacity, but basically the main benefit is you have somewhere over here at the center of everything, OneLake. So how is the data coming from your SQL database to OneLake? And the magic is it's done automatically. How? You have automatic mirroring. Automatic mirror. That's one of the key benefits. And it's really done completely automatic, means you have change data capture automatically activated on your database engine. Then you have the Delta converter that creates Delta files out of your SQL data. And then you have the mirroring service that mirrors the data in near real time. So basically your data ends up in OneLake as Parquet files. So this is not a database in OneLake, it's Parquet. The standard open format of OneLake. So everything great, honestly. From there, you can create, for example, a Lakehouse on top. You could consume it through a variety of services. Let's simply point out, so there are several consuming services. Consume, like Power BI, of course. There's a special mode with Direct Lake. Let's have a look into that later. You can use notebooks. You can use pipelines for ETL. And of course, you could access the data with a data flow. So this is the consumer side. Oh, you have more options just to get an idea. And this is basically how everything integrates. So on one side, you have the standard of having a SQL database. This is behaving like a SQL database standard. On the other hand, you have the standard and open source Parquet format in your OneLake, and the main point is you have both, right? You could create a SQL database, then you would have a SQL database, or you could create a Lakehouse, then you would have punted files, but you won't have both, or warehouse when you need to rewrite, of course. So that's really the key. And everything is done automatically, and everything is done in near real time, and everything is done on top of your capacity. So that's a lot of selling points for me. So what's the benefit or what's the difference between choosing a Fabric SQL database versus choosing an Azure SQL database? So let's start with a Fabric SQL. So that's the Fabric part. Let's make it with a green head, so you know that's Fabric. So first you start off with having a SQL DB in Fabric. I will show you later how that works, but honestly it's quite simple. From there on, you have real-time change data capture, which means in real time the data that is changing on your SQL database is tracked. Then you have this automatic mirroring. That happens. And then you have the zero copy delta, which writes the data into your OneLake delta tables. So this is OneLake. Make it a little blue. This is OneLake. And from there on, you can work with your consumer side. So how would, in comparison, would the workflow look when you would use a traditional Azure SQL database? So this is like Azure. Oh no, I'm one area too low. Let's go a little bit higher. There we go. Azure SQL. So Azure is blue, so let's give it a blue hat. The Azure SQL database. So you start off with having an Azure SQL DB. It is comparable to your Fabric SQL DB. You need to create that, of course, in a resource group. You need a subscription and so on. From there on, you would need a manual pipeline. Right? From there on, you would need some kind of manual ETL. From there on, you would need some kind of batch processing, and you need to put that into some kind of data warehouse service to consume your data. And from there on, you could then use some consumer, for example, Power BI, to consume your data. So this is the story without Fabric, right? So it's complicated. It's, well, it takes time. It needs to be maintained. Don't think about all the possible errors and so on. So things are much, much easier with, in my opinion, with Fabric SQL database. So how does this famous automatic mirroring technology work in detail. So you have your Fabric SQL DB. Let's give it a green hat again, so you know this is like Fabric and I don't need to write it all the time. You have tables, user tables. There are system tables too. User tables like DBO orders or like DBO.customers. On these tables, you have data changes. These data changes are written, as always in SQL servers, in your transaction log or glog. So any insert, update, or delete is logged in your transaction log. These changes in the transaction log are captured. Is captured. Capture. And this then ends up in a service called change data capture, which delivers exact this stream of changes. The stream. So here ends your SQL database in Fabric, and this streams all the changes over to the mirroring service. So from here on, the mirroring service starts. Mirroring service. The mirroring service has as a first component a change detection. A change happened. From there on, there is a transform to the delta conversion. And this delta file is then written, right, to, well, you guess it, OneLake writer. So this is writing to OneLake. This is the end of the so-called mirroring service. And from there on, things are quite easy. You are now in OneLake storage. OneLake. And you have two endpoints here. Let's draw it blue because we are finally in OneLake. The first one are the Delta tables. And with Parquet and the log files. And the second one is the metadata and the schema info. So you have like two different write artifacts, but both are written by the OneLake writer. This is basically how the stuff works. So how then is the data organized in this OneLake storage? How can you find your data in OneLake? You will see it in my demonstration later, but let's have a conceptual look on that. So we start again with our workspace. In that workspace, you have the folder called SQL Database name. So let's say the SQL Database name is sales.SQL Database. So the first one, this one, is the DB name. And this one is the suffix that you need for Fabric CLI. You remember the suffix in the Fabric periodic table? This is the one. All the items, because you can name items with the same name. So the distinguisher is like in early times in MS-DOS. The distinguisher is a file of holder ending. This is a suffix. The suffix is SQL Database. So this is basically an item in your workspace, and within there you will find a tables folder. Tables. And in this tables folder, you will find all tables, obviously. So let's say one table is dbo.customer. And the second one is, let's say, dbo.orders. And the third one, let's say it's like dbo.products. And inside of each of these tables is the Delta log. With the JSON files, 0.00000.json. The Parquet file, part -0, I don't know all the zeros, .parquet. And the part 1 Parquet, and the part 2 Parquet, and so on. So this is true for and of course the .1 JSON. Right, so this structure is replicated to all different tables. So it's the same structure, not replicated. Same structure for all different tables, and you will find it. And you can simply select your folder, right-click on it, and say, please create a table in my Lakehouse. Create table. In my Lakehouse out of that data. And this table is also then a near real-time sync to your SQL Server. You will see that in the demonstration later. But it's fantastic, honestly. It's really cool. You have one special case, I think, which is the OneLake integration. You all know and love Power BI. Power BI has this feature where you can go directly to OneLake. You don't have to go through SQL endpoints. So how is the SQL database with the OneLake application working with Power BI Direct Lake? So the question here is Direct Lake. How does this work? So again, we start with our SQL DB. The SQL DB has transactions, as we talked about, like updates, inserts, deletes, transaction. 1 to 5 seconds. These transactions are replicated to the automatic mirror. So you have like a near real-time replication. It's near real-time. It's not real-time, of course. For real-time, you have real-time. Out of the automatic mirror, after 1 to 5 seconds, the Delta files are created, and the Delta files then are stored in our OneLake structure in Parquet format. Delta tables. So from there on, you have this capability of Direct Lake. And as the name implies, you can go directly to the OneLake data. You don't need import here, so you can directly create the semantic lake model without import. So no import. Direct semantic model, which means you have a direct read from your OneLake. This then is cached in memory, which means that you can use it for query from Power BI. So this is how it works. Power BI has a query on the in-memory cache of your semantic model, which makes a direct read from your OneLake Delta Parquet file, which uses the automated mirrored data from your SQL database. So basically, you have exactly this lag plus some write time. So that's amazing. Given the fact that this is even not real time, it's near real time, which means you don't have to pay for real time. That's a huge difference. So how is this stuff integrated into security, you might ask? So let's talk a little bit about security. Well, for authentication, we have only Entra ID. And of course, managed identity. But managed identity is also an Entra ID. So only Entra ID authentication is possible in Fabric SQL database. When you then head over to your SQL database, SQL DB, you have the DB roles. You have schema permissions. You have role level security. And you have object permissions. And you have dynamic data masking. So from there on, you have like two different areas. As always in SQL Server, you have the schema and the object permissions. You have the DB roles, which you can map to Entra ID, and you have the role level security, and you have dynamic data masking in place. So this is like the SQL Server box, where you have your SQL Server security in. Then all the stuff is going to OneLake. And in OneLake, you have all the good stuff that you know from OneLake, like the workspace permissions, like the item permissions. Just remember, in between there's a mirror, automatic mirroring service. And you have OneLake security. OneLake security means that you have all the good stuff like column level security, like row level security, and so on. So just be aware that we have different places where you can apply stuff, right? And then you have Power BI, for example, is for consumption, Power BI. And in Power BI, you could have also the report, row level security, and you have also different roles. So things are getting a little bit complicated because you see you have DB roles on top here. You have permissions, workspace and item permissions in OneLake. You have row level security at a variety of possible places. So you need some kind of good governance in general. So you need to define where to set which kind of access rights. And it's not so easy, right? There are arguments to set that stuff in a warehouse area because you have different capabilities or everything in OneLake and so on. So things are a little bit more tricky than at the first glimpse. But let's talk about security in a different session. Let's go to all the community questions and the community area. So in general, the adoption of the SQL database in the community was very, very positive. There's a lot of excitement about a unified OLTP and analytics in one platform. There were questions about when to use what, when to use SQL database, when to use Fabric database, interest a lot in automatic mirroring and direct lake integration, and so on. So let's go a little bit. First one, when to use what. SQL and Fabric, when analytics integration is your primary goal, but you need a solid foundation for your applications. Azure SQL, when you need some kind of standalone OLTP, or you are a heavy Azure user and Azure is your main platform. So key insight, it's not a replacement, it's a complement for analytics scenarios. Discussion 2 was about mirroring latency. How about real-world experiences from mirroring latency? Users sharing real-world mirroring latency observations like typical latency 5 to 30 seconds for small changes, minutes or hours for bulk or large operations, and some users even reported inconsistencies, but this was in the preview phase. So bottom line is the initial thing can take a little bit longer than expected. The CDC changes, so once the stuff is initially replicated, runs blazingly fast. When you do schema changes, this can have temporary delays. But in general, once the things are up and running, it's really, really fast. Next one is about, hey, GraphQL integration, right? Because you could put GraphQL as a REST interface on top of SQL. This generated just a lot of excitement. So finally, I can build apps directly on my database without writing REST endpoints. So this is simply cool, right? Question was, direct lake and SQL database, is this the perfect combo? Question was, hey, when I use Power BI and mirror the stuff with automatic mirroring directly to OneLake, is this the way to go? So in general, yes, it is a perfect combo. You have to take into account when you have bulk loads initially that this can take some time, but in general, it's really, really cool. Question were also about migration from SQL Server, experience sharing. Deckpack, for example, works quite well, but you will find your own paths. You can do it with pipelines. There are several very well documented ways. So basically, this was like the main questions from the community side. One thing that's maybe worth mentioning, where does my data physically reside? So from the SQL Server, it's in the SQL Server storage layer still. The mirrored copy is in the OneLake as Delta Parquet files. Both are in your Fabric tenant region. So when the place of your data is important, well, that can be an point. That's from the architectural perspective. Let's jump over to our demonstrations. So here we are with our demonstration. First, as always in Fabric, we will create a workspace called Fabric SQL. And next one we will create a SQL database, obviously. This SQL databases are very easy to create. We simply need to provide a new SQL database name. And once we have typed that name in, the database will be created in the background. What is created is actually very similar to an Azure SQL database with built-in mirroring. So this takes a little bit, but as you will see, not so long. By the way, I have cut it out very long wait times. So the experience that you might get when you try it on your own can be a little bit different from the one that we have here in the portal now. We open the SQL database, and next we import sample data. On the left side, there's a big button that you can select sample data. This will take some time, so I've cut that out. It's quite important that you do not modify the database during this import because there's a background import running. So our result is that we have supply chain analytics database. We can create a new SQL query very easily because we can use Copilot. So we simply write a comment and then wait some seconds, and Copilot will suggest the proper SQL syntax, or more or less proper. So we have to check. It's like Copilot, it's not an autopilot. So this is fairly simple. That works. And we know that it's runnable, and we can then explain the query with Copilot again which is very nice for documentations, co-workers, and so on. So I highly recommend to do that and to use Copilot for exactly that. Next one is that we create a new query and insert some data and create a view. So we create a new table, supply chain warehouse, and to create a view on top of that. That's running, that's inserting some random data, nothing really special. So we can not only query data on the SQL database, we can also insert data. We can create new schemas. This is a supply chain schema that we create. And once we refresh our database, we see we have not only sales, but we have supply chain with all the tables and all the data in there. So that works. It's of course it's a SQL database. You can expect that, but since it's a SQL database integrated in the Fabric platform, it's quite important to get some base on that. By the way, you see the new API for GraphQL button on top. We have talked about that in the architectural discussion. There you can very simply create a new GraphQL endpoint from the SQL database, which can be very, very handy. So let's import some additional data directly in the SQL database. So let's combine Fabric items. In this case, we will use a data flow. And from the data flow, we will get data and then import from an open OData endpoint new data in our SQL Server. It's fairly simple. I've already put that in my clipboard. And so it's like next, finish experience, basically. And once we have that OData endpoint, we can select the appropriate table. In this case, we want to select the suppliers. You can select as many as you want. See, it's bottom down here. And we will get a preview, and then we can create, and this will import our table in the Power Query in the data flow Gen 2. And once we have imported it, we need to define a target, the export target. So this takes a little bit until the OData endpoint is loaded. And on the bottom right, you see the data destination. Don't be confused by Copilot, by the way, because the publish button is under Copilot, but it's not related to. In this case, we will select our SQL database as a target. That's quite handy, and we can import from a data flow Gen 2 data directly in the SQL database. So once we have hit our SQL database target, then we can select the appropriate SQL database. And we see all others. You could import into Lakehouses, you could import into warehouses, and you see as a default destination directly our supply chain database. So we will go with SQL database here, and then there will be a selector where we can select our, see it here, the SQL database target connection is Fabric SQL that we have created before. And so it's like next, and now we see all our SQL databases on the left hand, the workspaces with SQL databases. So you see the Fabric SQL workspace here, and we can expand this workspace, and then we will see our SQL database that we can select as a target. So it's very, very simple. It's a little bit like Explorer, Windows File Explorer experience. We have selected our database, and then we can save the settings. We could adjust the source type and destination, but since this is demonstration data, everything is great. I mean, so great. So there you see the publish button, which is a little bit confusing because it's in a UX way under the Copilot panel. But after some seconds, I have cut that out here. We can refresh the view, and you will just see that our data is now in here in the SQL database and available. So that's pretty cool, and gives us new opportunities, not only to store data in the SQL database, but also to import. There we see the suppliers. Yeah, there we go. Not only, but to get data into the SQL Server. Just imagine one of the hero cases is that you create applications on top of SQL database and Fabric. So you could create applications and then import data from other locations in the SQL database or from the SQL database then straight into OneLake. So I think this is quite an interesting and fascinating pathway that you can use, and that's cool, and it gives you real new opportunities. So well, that's basically the idea of having the data inside of the SQL Server, and from there on we can jump over and it makes the data usable in our OneLake. So what we will do next is we will wait. So that's basically what you're doing now. We will wait a second until the data is replicated into the SQL Server, and then we can execute some queries, of course, on the newly created data, and we can create a view on the supply chain view on the newly created data, which is quite cool. And once we've done that, we will see that there's a view that the data is replicated into OneLake. So that's what's happening basically next. So this is like this is all famous 5 seconds, right? That Fabric needs to replicate the data from the SQL database into OneLake. It's like I'm bridging that here, and now we can create a new Lakehouse, and in this new Lakehouse, then we can import our data from OneLake. Well, it's not import; it's like shortcutting data. We'll see it in a second. It's just a demo Lakehouse. It's very fast created. And now we can say, hey, we want to get data in here from the files. You see it here. There we go. Yeah. And we can say, hey, let's create a new shortcut from OneLake. So we're shortcutting the data from OneLake in our files area. And there you see we selected the database, and we can expand the tables. Select all the databases that we want to mirror and then tables with these databases. And once we have done that, you see the folder structure that we have talked about in the architecture session. And now we can create a table out of that mirrored data. So it looks complicated, but in the end it's really simple, because we need to select the format, because we create out of a SQL database with near real-time mirroring in OneLake, a new real-time mirrored version of a shortcut in a Lakehouse. So what we're ending up is like a SQL endpoint in a Lakehouse from a SQL endpoint in SQL database. But of course, that's not the point. The point is that we can adopt from a variety of SQL databases the data and process it through all the analytics lorries in Microsoft Fabric. And that's, I think it's a very important and honestly really fantastic point. And well, thanks for being here with me and going through all that, and let's use that stuff to build really great and cool applications. You see, data is here, mission accomplished, everything is great. Thanks for attending. When you don't want to miss the next episode of Fabric Friday or any other video that I release, just hit subscribe on this YouTube channel and you will get a notification once a new video pops up.